Alright, this is the frictional force on a rolling ball. Let's just start as usual by thinking about a few of the things here. I for the ball is 2/5 m big R squared. We'll assume the mass, and that's the only m and the big R that we're going to use in here. Now if you've done the conservation of energy where you did the mgh equals 1/2 m v squared linear kinetic energy plus 1/2 I omega squared rotational kinetic energy, you will know that you can get to the point where v equals the square root of 10 gh over 7. I know that looks like a 2, but it's actually a 7. We know that the ball rolling down this little slope here is going to have a frictional force applied that way, and that frictional force is what causes the rotation. It causes the torque, and that causes the ball to rotate. Now the thing that people forget is that the actual acceleration of the ball down that slope is also going to be less because of that frictional force. Remember, the force acting away from the center of mass not only will cause a torque, but it will actually act as a force to slow down that ball's linear acceleration. So the actual linear acceleration, if we did the vectors, I know that you're all familiar, the actual force parallel to the ramp, you're probably thinking, is mg sine theta. But the actual net force is mg sine theta minus the frictional force. So the acceleration of the ball down that ramp would actually be that divided by m. So don't forget the fact that the frictional force also acts in the opposite direction to the component of the gravitational force that accelerates something down a slope. Okay, so hopefully we've got that all clear. Torque is equal to rotational inertia times angular acceleration. In this case the torque is going to be the friction times the radius is equal to rotational inertia times angular acceleration. A few other little things that are going to help us along the way. D times the sine of theta equals h. So h equals d sine of theta, or d equals h over sine of theta. We've got the omega f, that's for at the bottom of the ramp. Let's have a little think about some of our other little equations here. Kinematics coming in here. Often a good idea when you're trying to solve a problem is to have a think and write down anything you can. Omega f squared equals omega I squared plus 2a theta. Alright, theta being the number of radians, not the angle. So don't get confused by those two thetas that I just put there. If I want omega f instead of vf, we all know that omega r equals v. So we only need to divide the v by the r to get the omega. So if I actually want omega f, then yeah, I've got that 10 gh over 7 all divided by r. That's our omega f. And if I want the actual radians, remembering again that distance, this distance here, okay, in terms of the number of revolutions that ball is going to make, this is the old distance is equal to theta, or the number of radians, I'll put a little r, times big R, the radius. So we've already got, so if I want to know the radians, I just divide the distance by r. Right, so the distance was h over sine theta. H over sine theta times r. So h over r sine theta is actually equal to theta r, or the radians. Now we're getting closer to being able to use this little formula. I'm thinking what we're actually after here is, because you can see once we get to the point that we've got alpha, we're looking good. And we've already got this one here. So alpha equals omega f squared divided by 2 theta r. So let's write that down. Theta f squared is going to be this one, right? Squared, which is just 10gh over 7. But remember, we had divided that all by r, so that's r squared. And we're dividing that all by 2 theta r, which means 2 theta r is that. So we now put a 2h down here and an r sine theta, and that should be our alpha. Let's do our cancellings. R, H, and what are we left with? 10g sine theta. No, I didn't do my 2. Sorry. 2's into 10. 5g sine theta all over 7r. Now that's our alpha. How close are we getting now? So that's my alpha. 5g sine theta over 7r. Looking good. Now from up here we can say that the friction is equal to I alpha all divided by r. So I was 2/5 mr squared times alpha, which is 5g sine theta all over 7r, and this is all divided by r, so that all becomes r squared. So that's our expression for frictional force. All we need to do now is do our cancellings. And what have we got? We've got 2mg sine theta all divided by 7. And we are done. Nice job.